Before we get started, little bit of housekeeping item from our legal team, making sure all the things that we say here, that's not taken out or used wrongly. So let me get started to talk about who we are, what are some of our innovations, and what are some of our journey. What's our take on AI, and how are we solving some of the problems using AI, and Q&A. So who are we? We are Intercontinental Exchange. We are a data and technology company, and we use our expertise to inspire innovation and create opportunities. So just to give some perspective, we have three verticals: exchanges. So in exchanges, you might have heard about New York Stock Exchange. That is the largest stock exchange group in the world, with 5 equities exchanges and 2 options exchanges. We offer our venues for icon and entrepreneurs to bring their ideas, and we give opportunity to raise capital and change the world. Along with that, we have futures trading venues also and clearing houses. We are the first to digitize exchanges and to be the leader of price discovery and capital raising. On our fixed income and data services side, we are streamlining the systems for data delivery, and we provide high-quality market-leading data and the tools. The idea is to provide all the widgets for making financial decisions to trade at our venues or any other place. On the mortgage technology side, we are automating the industry. We are digitizing entire mortgage process to reduce the cost and increase efficiencies. And we'll talk more about that as we go through the slide deck. Before we get started on the AI, I'll walk through some of the things that we have innovated, as well as some of my journey. So I started back in 2002 as an engineer, started coding in C++ for medical imaging, fell in love with low-level coding, so fell in love with how the code gets compiled, interacts with the chip, and how we can bring efficiency for any kind of processing, medical imaging, or any other database backend and things like that. Then I moved to the States in 2007, started working for New York Stock Exchange. So I was writing trading algorithm for our trading platform. And in 2009, I got the opportunity to rewrite an ancient 30-year-old trading platform, soup to nuts, and roll out at New York Stock Exchange. Took us 3 years to do that thing, and that's the first time I got the experience to build a trading platform end-to-end. And right after that, ICE acquired New York Stock Exchange, and Intercontinental Exchange had this idea that we will have a small team which can power all our exchanges. So the idea was to create a single code base, single package, which can be configurable for any exchange venues or any platform that we have. So that started our journey of building the Pillar trading platform. Many people do not know about this. It's a distributed computing system. We have been using InfiniBand for inter-process communication in the trading platform. So people talk about InfiniBand on the context of AI right now, but we have been using that since 2012. So 2012 to 2016, I worked at New York Stock Exchange, architected many of the parts, which is building the trading platform. At that point of time, rolled out 5 of the exchanges, and then I got an opportunity to run a fintech startup as a CTO. So there, we built an analytics platform on Google Cloud for Bank of America. The idea was, again, same kind of thing, use a low-level coding language, write a compiler and interpreter to do the backtesting on the data at a very low frequency. So the idea was that you can do backtest very fast with a large amount of data. So I got a taste of the cloud computing and what cloud and scalable compute can bring. So you can scale it horizontally and bring it down as and when we need. And then soon after that, I was asked to come back to New York Stock Exchange and solve some other problems. So when I came back, there are two of the big systems that I led and built, and very proud of putting that together in the timeline that was needed. So one of the system consolidates all the market data for equities and options world called Opera. Arguably, it's the largest real-time market data consolidation platform. Every trade that happens in US equities and options space needs to be consolidated in that system in real time. So just to give some perspective, between 9:30 and 4 o'clock, we processed 200 billion transactions with 20 microsecond latency at the median. And that's just not the full day of capacity. That system also has the throughput of 220 million messages a second. Okay, think about that, right? So we had to literally optimize everything, soup to nuts, from network driver to compiler optimization to how much memory should sit on the L1 cache to anything and everything. Any place that we found 15 nanosecond that we could share, we did that, and that's how we achieved that latency. So along with that, around the same time, I also led the teams to build an analytics platform for our regulation team to take billions of transactions that happens in our exchanges as well as across US to mine the data to figure out, if we can analyze the data and then, find patterns to figure out if somebody is trying to game the market or not. That's the first time I brought cloud to Intercontinental Exchange, and it's a massive deployment. I spoke about this in detail at AWS reInvent. The link is on YouTube. If anybody is interested, please look it up. Again, same kind of thing, C++ based analytical engine, take 700 billion transactions every day in real time, take it to the cloud, scale up to 150 to 200 machines, and then do the data mining. Right after that, when I finished that one, I was thinking that all these heuristic-based analytics is traditional and old school. Let's do some machine learning on time series data. So then I stood up a team to start digging into machine learning and deep learning on time series data. And then ChatGPT happened, and then we started looking at a transformer model. So then we took some BERT and BART-based model, build AI on news and social media data. And then right after that, I was asked to oversee all AI initiatives at ICE. So I'm right now leading the AI Center of Excellence. So what's our take on AI? We are a B2B business. We leverage unstructured data and our network across exchanges and mortgage businesses to create innovative products. We see AI as a technology solution to solve a problem, and we invest significant amount of time understanding the stack so that we can optimize. We also established AI Center of Excellence, like I said, so that we can innovate with all the necessary guardrails that is needed. There are a few ground rules that we have established that we are not going to do pricing decision or underwriting decisions, or we are not going to use generative AI for, automatically recommend investment decisions and things like that. But there are a lot of opportunity, and I'm going to show some of these things. There are some key consideration, risks and challenges and mitigation that we know about. And we pay attention to all these things. So when we are building AI solutions or applications or deployment, we are making sure that we track all the conversation that is going into the model. For data privacy and controls, we are putting checks and balances. We are relying on open source and proprietary model, having licensing agreement with whoever is providing the model. Same goes for CyberSec, InfoSec. And then we have a governance framework, and we have updated our AI SDLC for biases, data quality, model hallucination, and things like that. So just to give some perspective, there are three broader segments of problems that we are solving. One is unstructured data. So people do not know that we are one of the largest aggregator of data from across the world, and we extract information out of that and normalize, and that is part of our reference data offering. On our data services side, same thing we do for public records data for properties. So we collect data from all the 3,000 odd counties, like deed, mortgages, you name, every kind of document. We extract information out of those documents and normalize to sell as data products. There is another thing that we do on the loan origination side. We extract information from, let's say, you upload a pay stub or checkbook and things like that. So we are processing millions of pages every single day, and we are providing these endpoints to loan originators so that we can extract structured data out of that. So that is a big segment where we are using heavily. We are using AI heavily. The second segment is data endpoints. So we have various products to give access to the data. Think of it like, dashboard or query terminal or servicing endpoint and things like that. We are adding AI-based features as value-added services. And the last segment is productivity improvement. So think of those like GitHub Copilot or Microsoft Copilot or any other thing. So that's how we have broken down. Let me walk you through some of the problems that we are solving to give better idea. This is a product on our mortgage offering side. This is a regulatory document system, basically. So if anybody is trying to look at the regulatory documents, we have this document hosted. Recently, we launched a natural language-based chat or Q&A endpoint so that we can extract information out of that. Same kind of thing is there for rules and regulation across ICE. This is one example. There is another important thing. This is part of our product which is offered to the MLSs. So realtors use this product. We have the phone app as well as web application. And you can upload an image, and we extract information out of that. For example, whether this is the front of the house, or red door, and what kind of house it is, whether it is a kitchen and bedroom and things like that. So we use AI for that. Another application I can tell you is that we are also modernizing the appraiser lifecycle. So you can upload an image. So we extract information out of that image. On top of that, we combine that with permit data that is coming out of counties to give valuation. So that's how we are improving and innovating on the mortgage life cycle. So this is another example of that. This is one thing that we built last year, spent about 3-4 months building this platform. So this is going to be part of our MLS platform offering. So you can see that there is a structured data, and there is endpoint. How can you ask a natural language question and get the right information? And this is the same kind of usage which is there across ICE for various structured data offering. So how does this work? So traditionally, or at a very high level, if you think about it, there is a backend database and there is a front-end application. People may say that, hey, take this data, put it into some new database, and then everything will work. But then I started thinking that I cannot migrate all these applications, yet I need to roll out the value-added services with AI-based features. So what we did is that we created a side channel where we can provide the same feature without destabilizing the existing ecosystem. So what we did is that we took metadata out of the database, and then we put that metadata into a vector database with embedding. So think of it like tables and columns and things like that. And typically, people for legacy region may not have named the column properly. Let's say the column says C1 or something like that. Now we put some more information for that column that, okay, this column has this kind of information in English language. So we have table, column, and some additional information. So when the question comes, we basically search in the vector database, get the relevant table and column information. Then we put that information as a prompt to the LLM so that LLM can generate the nearly accurate query that we have. Okay, and we have benchmarking and other things on top of that that I'm going to talk about. But this is how we have built or we are using a language model along with vector embedding to serve the purpose of natural language query. Okay, so just to take it a little further, the API endpoint are there, and this is how the microservices and database access looks like. The next example I'm going to talk about is if you upload an image of a property, the idea was to find similar kind of images. So we use a clip model from OpenAI that is open source, and then did some additional work to house this thing and achieve this one, okay? Another cool thing that we are doing is using language model in sentiment analysis. So recently we did an announcement that we are partnering with Reddit. So Reddit got listed at New York Stock Exchange, and on our data services side, we are partnering with Reddit to take their data, extract the necessary information, which is related to the trading data, so entity extraction and summary, and then do the sentiment analysis along with that. But that's not the end of it, right? That's easy to do. What we are doing on top of that is creating a business ontology. So think of it like a graph. So here I have example of Elon and Starlink and Tesla. Let's say some conversation is happening about some topic. You can always correlate that to some stock ticker and anything like that. But there are other information which are out there which can be correlated. This all is possible because we have our reference data offering, and this comes on top of that. This all started when we started looking at Dow Jones news data to figure out how we can do entity extraction out of that, okay? So what we did is that we looked at the news data and figured out that unstructured data is there. How can we train a model, small language model, hyper-optimize, can run on CPUs, and do the sentiment analysis of that. So you can see on the right side, there is no stock ticker information, but we are accurately able to convert that to stock ticker as well as sentiment analysis. How does it look? You can see there is a unstructured data, then we clean the data, then there is a model which is summarizing it, then there is a fine-tuned bot model which is analyzing the information and sentiment analysis. We are extending this to our derivatives product right now, and the fine-tuning and all this work is going on. This is the system which gave us a lot of maturity. So we have a heuristic engine for doing the real-time kickout. And what we did, you can see this has everything possible. So we literally had to build a neural net deep learning model, two-layer neural net deep learning model to categorize the information, summary and sentiment analysis, entity extraction that I mentioned about. But one of the key thing on the right side, you can see there is a decision engine. The decision engine was complex to build because our idea is to give analysts what they were doing manually to all the tools that he needed and short circuit the lifecycle they have when they are looking at the real-time alert as well as reading a bunch of things. So we spend a lot of time looking at the historical pattern of that, did feature engineering, and literally build a decision engine to make the automated decision and give them saying that, okay, the alert came, but because the news came out, that's why this is a false alert. So that's the idea of it. But this is an implementation where you can see multiple models working together to solve a problem. Next thing is document processing. So what we are doing is that, like I said, we are processing all the county record and property data. So what we do is that we have a document management and classification system. A document automatically gets housed, automatically gets classified using models. So we do fine tuning. Sometimes we are using large language model also. Data extraction, typically people annotate, and you have seen OCR and AI-based data extraction for a long period of time. But now with LLM and VLM, this has become really good. You don't have to train, annotate, and train. So that development cycle is short-circuited, and we are getting some very good accuracy out of that. The way it works is that you take a giant PDF, and then you break the PDF into pages, and then basically that gets converted into LLM. Then you use prompting to convert that into JSON, and then you extract information out of that, and then you store into a DB. There is a lot more complex stuff that happens behind the scene for correlating the coordinate on the images and pages and things like that. That's what we are doing. Another implementation I can tell on our servicing endpoint, loan servicing endpoint, There was textual information which was sitting on the right side of the screen. You can see summary of loan. So when the servicing customer care gets a call, they have information about a loan for a long period of time. The idea was to figure out whether it is a payment or escrow or insurance or any of the thing. So how do you do it? So we looked at all the information on structured data, created automatic classifier of that, and when the call comes in real time, we are able to extract that information and summarize. And then you can see there is a thumbs up and thumbs down. Sometimes you have to give the end user so that we can short circuit that and the feedback loop. Okay. That's how the stack looks like, and you can see there is a nodes cleaner, data normalizer. All those things are there. Each of the things are needed, for the stack. There are quite a number of use cases that we are working at AI Center of Excellence. Some of the things I already covered. One of the things is a multilingual model. So we have, like I said, across US, we are collecting, outside of US, we are collecting data in non-English language. So there is a lot of work going on to extract information out of that also. All right, so coming back to process, so when I was asked to oversee all AI initiatives across ICE, I was thinking that how do I do it, right? It's a large company. We have about 14,000 people right now. And there is a lot of hype around AI, and people want to have AI access. But so what I did is that, okay, let's launch a program, launch an idea intake form. And I asked 4 or 5 very specific questions. What is the problem you are trying to solve? What is the impact of this problem? And do we have access to an SME who can work with us? And do we have access to the data? Or do we have ownership rights of the data? What it did is that people had to spend some time understanding the data, the implementation, and things like that before submitting the idea. Then after the approval, it lands at our desk. We look at it. We have follow-up calls. We do the solutions design. And if it makes sense to invest in that, then we start working on that, and then we provide an avenue for collaboration so that we spread the word across the company. So that's the process part of it. We are doing at scale. Some very cool ideas came out of that, and we could find a lot of coherence in all the things that we are doing. So if you plan to scale out across the company, yet innovate, have all the necessary guardrails, that's the way to go. Now people ask me, what is AI Center of Excellence? So Center of Excellence is the way we have organized it to streamline all AI workloads, not only by preaching, but providing a platform for effective experimentation with all the necessary governance and guardrails. And not only just experimentation, you have to provide a way to seamlessly deploy that thing. So typically you will see in any organization there are product and application team. Product teams would be looking at new features, and application teams are busy building those features. Infra teams are responsible for providing the infrastructure, the capacity planning and management. There are some process-related things, approval chain, project management, and so on and so forth. And then what we are doing right now is we are sitting somewhere in the middle of all this thing, collaborating with all the groups, making sure that product and application teams are educated to innovate, and we are building some features, helping them out. AI Center of Excellence at my end is set up as a hub and spoke model. At the hub of it, my team is responsible for providing the platform as well as building some of the solutions. And we have extended the spoke to all the rest of the team so that they can also innovate and build. Now, let's look at the deployment, right? So what we are doing is that we are a sophisticated data center owner. We have a really sophisticated data center by virtue of operating New York Stock Exchange and low latency, and we have ICE Global Network to take our data in a secured way here and across the globe also. So we have deep expertise in data center, the network architecture, server racks, and things like that. So we want to utilize that. But one thing to keep in mind that all the hyperscalers or cloud providers are providing a lot of innovation tools, techniques, and some of the servers and next generation. So what we are building right now, that platform as a hybrid cloud, so that we can scale up to any of the cloud and utilize the feature of those cloud providers. and we can make a judgment call where to deploy at that point of time. But we made a single entry point in our data center so that all AI workload can work. Going to the next step, AI plumbing, what it takes, right? So typically an AI engineer will say that, hey, I need an IDE, I need packages, and I need access to the model. And so we said, okay, fine, let's streamline all those things. So you can see on the left side, there is a browser-based Jupyter Hub. Some people use VS Code. We give them API access and Python packages and things like that. On the top of the screen, you can see we need a scalable storage because we're dealing with images and text, and very soon we'll be dealing with videos and audios. And in our data center right now, we have access to CPU compute cluster. So basically, any kind of pre-processing or some classification model or machine learning model can work there. So we are putting that there. We don't have GPUs yet, but we are in the process of getting the GPUs. But at the same time, you need to build somewhere. So what we are doing is that we are using AWS, Azure, GCP, so that we can utilize the GPUs and run large models there. We also are using some of the managed services like Bedrock or OpenAI through Azure and things like that, where we have partnership. All right, so let's understand a little bit, which is near and dear to my heart, because that's where I spend a lot of time optimizing the stack. Typically, any compute, anywhere you go, you will have your hardware stack. Then if you have to scale out all the things, you have to rely on containers, okay? And there is no way any of these things can be scalable without using the containers. So there will be a host OS, and then there will be a driver, right? Then you need a Docker engine, and then the application containers on top of that sits for different microservices that we are deploying, right? So the toolkit needs to be going into the container on the top of it, then you can deploy like that. One thing that happens, and this is coming back from my low-level coding background, and there are various ways to do this thing, but remember, once the code is written, it needs to be compiled into a machine understandable format, and at runtime, that runtime will read the machine understandable format and provide you the serving endpoint, right? And then you still have containers, so you have to deal with the container registry and images and all the whole 9 yards around that. But I have put some links here. Feel free to click through that and understand more. Just to take a little further into this, on top of that, you can see that various kind of client requests, whether it is human being or APIs, you can rely on HTTP or gRPC if you're looking for performance. The request response will come, then there will be a scheduling queue will be needed because we are dealing with parallel processing and asynchronous API and things like that. Then you need a framework backend where it is getting hosted, right? And that can change, any of these things can change, but at a minimum, we need all these things, right? And there is a model repo that is needed and model management, right? So that's how the interaction works. And then at the bottom, you can see CPU, GPU, and you can schedule and you can do all those things. And then you need all kind of monitoring and status check and health report. So that is at the bottom of the screen, right? That's how, on a high level, the stack looks like. All right, coming back to model serving, just making sure that we understand that these are all the things we need, right? Parallel processing, asynchronous API, adaptive batching, REST API, gRPCs, and monitoring log, right? We spend a lot of time understanding how and which of the runtimes would work. So you can see there is Torch Serve and TensorFlow Serving. Those are two known ones. And then Nvidia Triton is also there. These are all the things. You would need runtime as well as a serving platform, right? So let's look at the serving platform. So basically, now you are reliant on, let's say, AWS SageMaker or Vertex AI, right? But what if I need to build and deploy myself, right, as a runtime? So all these models, are compiled, and you have the serving runtime. This platform basically provides a scalable way to deploy and scale at will, right, basically. So we are relying on Kserve right now for doing that thing. Kserve came out of Kubeflow, Kubernetes world, open source right now, and available for serving. There is a lot of flexibility you can get, like you're not limited by how much bandwidth or what is the throughput that you needed. So we spend a lot of time experimenting with all these things. All right, so how does the stack looks like? So at the bottom, you can see, all the different kind of compute you can get, Kubernetes, and we are relying on OpenShift, managed version of Kubernetes right now. The Knative and Istio, my team member Shobi is here. He spent a lot of time understanding all the details of that, and Kserve, right? And on top of that, you will have PyTorch, TensorFlow, Hugging Face, and all those kind of thing, right? How does our deployment look like? So this is on a very high level. You can see all the things that I was talking about, all the different use cases that comes to one API endpoint. We have classification model, retrieval model, extraction model, and then large language models are a different beast altogether, right? So we have a router for that. On the right side, you can see I have ICE Olama. So Olama, for the people who do not know, it's an open source way to take a large language model. It provides a way to deploy the model as well as use them. We are also relying on every model provider who are there, and we have relationship with them. We do enterprise agreement. So Bedrock, through Bedrock, we have access to Nova model or Claude. Same goes for OpenAI on Azure, Databricks, DBRX, and things like that, okay? All right, let's get to little more details of this. Now we know that we have access to container. How do we elastically scale it out, right? So you can see one of the things that we are doing is that we are making a seamless layer from our data center to the cloud. So literally you can take one of the Docker container, deploy in the cloud so that it can run. So our control plane and management plane resides in our data center. And through network connection, we take a container using, let's say, EC2 instance on AWS to deploy the container. On top of that, we are also building a scalable storage layer so that the data can be hydrated on both sides. So any of the applications can see a single namespace, whether it is in our data center or in the cloud, right? So that's some of the details that we are doing. The next thing, right? So code to production, release cycle. So what happens is that, like I said, we are trying to make the life easier for the engineers. So we have Jenkins pipeline to build all these things. Then it goes into the OpenShift test clusters. And on top of that, same kind of things happens with the model serving. It gets packaged in the Jenkins pipeline, gets served in the Kserve environment. And this is, at the end of the day, microservices and API calls, right? The next thing, storage. If you want to know the role of the storage, you need to pay attention to this and then also look at this link in detail. At raw data, when you are dealing with petabytes of images and photographs and things like that, you need to have a faster storage to access those things because it is highly experimental and you have to refine the training data. Sometimes you have to do the cleaning and things like that. Then comes the model part of it. And you still need to train the model, deploy the model, quantize the model. The model needs to be housed somewhere. One thing people do not realize is that just extracting the data doesn't solve the problem because you still need access to the raw data for questions. So at the bottom of the screen, you can see we have a vector database there, and you need vectorization for the unstructured data also. So that's the role of the storage. So we are partnering with some of the storage providers right now to take their appliances, run it in our data center, and scale it out to AWS and have a seamless view of that. Now, optimized way to deploy. For example, let's say I'm dealing with machine learning model and deep learning model and small language model. What we are doing is that we are deploying on the left side on Kserve environment. And my GPU workload spans from data center to the cloud seamlessly. So that's how the storage get access on both sides. And I can run some classification model on-prem and the extraction model in the cloud. So wherever the data is, the compute needs to be closer to that to optimize, and you can extract information out of that. One other question people ask, what happens if I have to archive the data somewhere? So you can think like any application which is already archived in the on-prem, you can continue to archive that. If somebody wants to use the S3 and all the archival and lifecycle, you can do that also. Testing. This is one of the first thing, any system that I have built, the first thing we build is a testing framework. And when we were looking at all these machine learning and large language model, a lot of focus went into building the testing framework, also making sure that we deploy at scale. This is an example of the text to SQL evaluation. We did syntax evaluation as well as execution matching. We broke the queries into based on complexity. On the right side, you can see the columns are there. So extra hard queries with multiple joins, multiple tables and things like that, to hard, to medium, to easy, could be single table with few query parameters kind of thing. And then we do precision and F1 score and all these things to make sure that whether it is working or not. This is just one example of that. This is happening for all our deployment. Performance testing, right? Goes without saying, what if thousands of requests or hundreds of thousands of requests come to your API endpoint? So you still have to build all the performance testing and all the Grafana dashboard. All right, so I'm at the tail end of it. I covered a lot. Just to give a little bit of summary, understand the problem, approach the solution from the first principle basis. That's what we tend to do. Try to understand everything before jumping into something. Then people ask me, where do we get started? So what we say is that take a high impact idea, build a platform for the broader usage. So we understood that our high impact area is unstructured data processing and data extraction. So we are doing that. The process is more important than the outcome. It goes without saying, more than 22 years of building technology, I know that if we do small thing, everything will add up. So reusable component, modular design, testing, all the process, every little detail is needed. There is another thing people say that, okay, this became too expensive. So I said that, okay, because it is highly dependent on the architecture, right? So if we can optimize each and every segment of the architecture, the cost will be effective, Constant create innovation. I told about the Opera plant that I built. Because of the form factor, I couldn't go beyond 3,000 odd cores, So what do? You get pushed into a corner to build all these things, so then you start thinking about how am I going to innovate here and look at every aspect of the stack. Literally from data structure optimization to memory optimization to, like I said, L1 cache, how much fits into that so that we can retrieve faster. And make the best use of resources you have, so wherever, whatever is there. So understand your ecosystem. We have our data center, we have our teams. You cannot change everything just for AI. AI is just a technology solution. And build the feature with the existing offering, keeping the desired final deployment in mind, so that think about any of the thing can be replaced. Today, the way the AI world is moving, any of the things can be changed. So keep it modular. So yeah, the switching cost should be close to none. So we have built API layer on top of any of the models so that we can drop in place and switch. That's it. Stay curious and keep building. Thank you.
So we may have time for one question, if somebody wants to. Okay.
Hi. Thanks for the great talk. I'm curious about your AI Center of Excellence, and like you talked about how you get a question in and you deliberate and figure out. What's your typical end-to-end time for that process? Like how long does it take to get from idea to delivered product?
There is no set time on it. So basically, typically what happens is once the ticket gets submitted, this gets approved by the head of technology and business unit. So we don't have a big management chain of approval. It can come from anybody in the company, but it gets approved at the top level. And we get the notification right away. So we go through it. My team spends a lot of time with that. And then what we do is that we talk to them, to figure out. And we ask a few questions like, what do you have this data? And then we establish ground truth for testing and things like that. So that process, few weeks time, and then let's say we have done classification or any other thing like extraction. then we know what to do with that. So pretty easy. And because we have automated all this pipeline, once you drop the code, it is quick to test right now. And we have created API endpoint and provided access to all the end users also. So there are two segments of people you can find. Sophisticated data scientists and not so sophisticated users. So sophisticated data scientist or ML engineer, they would always want tools at their disposal. So we help them with that, okay? But we give guidance like how to go about it. Not so sophisticated users, they are always looking for the dashboard, APIs, and things like that. So we have, depending on the use case, but it is pretty fast. There is one last question, sorry.
Oh, sure. We should be real quick.
What do you do to validate? Like you said, you have a decision at the end from using market data and alternative data, as well as for mortgages also there is a lot of data that you extract and you provide this information to the underwriter. How do you validate whether this using AI has improved the entire process?
Good point. So let's say you have pre-existing data, then that's golden, okay? Because comparing output is very good. Then on top of that, we write many rule-based engine also to make sure the data quality is good or not, okay? That's another kind of AI implementation that is going on at our end also. There is always human in the loop in the first stages. And then the other factor that we look at is the time to market. For example, when people were doing manual keying by reading the document and inputting, now we see about 30 to 50% improvement for time to market on that. So we have optimized. So we have figured out what is the KPIs for that and what is the success criteria. So we go over all those things. Like I said, in the question I asked, are you trying to reduce the time, cost, new feature, and things like that? So